It's great to have you here, Chris. You're a titan of the industry. You're a chief executive of Amercian Bureau of Shipping, which is one of the absolute leading classification societies, and somebody I think who has stood on the barricades for this new emerging sector now for quite some time. And I'm honored to have you here with me today. Maybe you would like to introduce yourself to the audience and your background and how you see this, see this.
No, I really appreciate it. And Mikal, thank you very much for having me here. For those that don't know ABS is a independent global marine and offshore organization that is in the business of certifying for safety reasons ships for insurance purposes. So we talked a lot about insurance this morning, but for a vessel owner or an offshore operator, in order to certify the asset, they actually have to go through an independent process as part of the regulatory framework to ensure that the vessel is certified. So as you can imagine, we at ABS are coming at this a little differently, but we are, in many ways right there on ground zero of what we were talking about, and really at the deck plate level when it comes to any new technology. This afternoon we're going to talk about new nuclear technology. We are the only class society that actually has a set of rules in order to certify nuclear power systems for marine and offshore systems. So we have already put together essentially a set of rules that with inputs, obviously in this case from other people to essentially for insurance purposes provide a level of comfort relative to safety. So that's a little bit about ABS, but I think that was important in terms of the context. Let me talk a little bit about what's going on in the maritime space, because I think that also will provide a little bit of color relative to some of these discussions. I mean, this industry is really going through, in many ways, we're in the early innings of what I would call a decade of change. And in some cases, quite frankly, it may not even be a decade. The timeline may get a little bit shorter. What we are seeing is a new language of shipping that has developed, really being driven by decarbonization. Moving forward, it used to be dollars per ton, now it's really CO2 reduction per ton. Obviously, the whole global industry is kind of positioned around the IMO, developing IMO framework that we see. We've got new boundary conditions as a result of this, and we've talked a little bit about them: safety, availability, scalability of fuels, and not just nuclear, but all fuels as they move towards getting to net zero by 2050. And also ports, infrastructure. So we've got those. We've got new shipping shapers that are driving this market, everything from what you read about in the paper in terms of geopolitical turbulence to regulations and to technologies. All of this in a lot of ways is actually changing even the relationships that we have, historical relationships relative to, let's say, the owner and the charterer, let's say the ship to the port. Because now with these international requirements coming in, port efficiencies drive shipping efficiencies moving forward. And also, quite frankly, with industry and government. So what you can see is there's a lot going on relative to where this industry is going. And if you put all that in perspective and you look at kind of the calculus to get to net zero by 2050, which has kind of been that international mantra, basically we need 70% zero carbon fuels, which is, quite frankly, that's 10 times more renewable energy that you have today. And we need about 30% carbon neutral fuels, which is about 100 times more carbon capture. But there's nowhere in this equation, and this is the point I'm making, that nuclear is mentioned. And I will tell you from where I sit, and I see the pace and speed of the curve, and I know we're talking, in terms of timelines, nuclear needs to be in that equation. You're not going to get to net zero by 2050 without bringing nuclear into the equation. And that's going to be, quite frankly, the challenge going forward relative to getting nuclear addressed specifically in the international regulations as well as the regional regulations, because this regulatory framework, has regional components as well as international components. So with all that being said, as a backdrop, when you look at, okay, new nuclear technology, and again, in my mind, from where I sit, is kind of one of five what I call really fundamental transformational technologies that we see in this industry. It's nuclear. I put carbon capture in there. I would put electrification in there, green hydrogen, electrification, carbon capture, and digitization. Those are the things that are there. But when you look at new nuclear technology, what you're really looking at is essentially three stories, and we'll talk a little bit about it. One is obviously what I talked about, which is kind of the global decarbonization solution going forward. But the other thing is, when you look at nuclear, we'll talk a little bit more about it, it is actually very much a commercial shipping disruptor. And when you look at this particular technology and the way ships are going to be run, and the ways everything is going to work, we're going to be using shipyards, even the whole commercial model in terms of financing will change. And the last thing that I want to mention is, and I think it's really, really important, as we move forward, I believe that the new nuclear technology will actually be a catalyst for a new generation of industrial policy. And I think the Admiral talked about it a little bit this morning, that brings together national security, economic security, and energy security. So, and I think that, here in the United States, with everything that's going on, there's a lot of discussion about a bipartisan effort to reinvigorate U.S. shipbuilding, to really strengthen the U.S. flag fleet for commercial reasons as well as for national security reasons. To be honest with you, new nuclear represents in many ways a generational opportunity for us as a country going forward. So there's a lot there to unpack, but there's kind of three stories that are, kind of basically developing.
Wonderful. Thanks, Chris. And, so I think, and you probably see this as well, right? We live in a world of headlines. We live in a world of press releases, arrangements being announced. We live in a world of perception. And there's no end to the amount of announcements we've seen over the last 4 or 5 years of how people are going to meet these climate goals. And what I'm finding when I'm traveling around the world and meeting with industry leaders in maritime and heavy industry, etc., is the story is very different, right? What they say in the press and what happens in the boardrooms and what happens in the conversations about what's real in those businesses is very different. And I think you said it right. The nuclear is often left out of those discussions at the headline level, at the surface level of all this. But like all beasts that rise from the deep, they come up and they approach the surface. I think people are starting to see the shadow of nuclear coming up towards them like a big whale here, and it's unstoppable in a sense. And what I'm hearing when I'm speaking to CEOs of liner companies, big tanker companies, speak to the energy executives, I speak to manufacturers, etc., is that this is what they expect to happen, and what they're trying to do is figure out how to do it. And I think I want to ask you something, because 5 years ago it was sort of, it might happen if they couldn't see the shadow of the thing coming from underneath, right? And it was, if nuclear was going to be part of this, then maybe they would get around to dealing with it. But now it's really a question of how are we going to do this? Now, when you go around and speak with owners, charterers, senior decision makers in our market, are you hearing that message coming through? And what are they saying? What is the collective crowd in the maritime industry now starting to see in their next 2 years?
Well, I mean, everybody now, as we move forward, is developing playbooks. You got a short game, mid game, and a long game, and we're seeing that right now relative to again, I go back to those boundary conditions: safety, availability, scalability, and affordability of fuels and infrastructure. And what they're seeing is, as they look at kind of what is required by 2030, 2040, 2050, and they're looking at kind of the pace and speed that is required and what is available now, I would not be surprised if you see a convergence of timelines. Okay, I mean, it's as you move forward. Okay, I think I heard this morning's session. Some of these, small modular reactors, it'll, be about 8 to 10 years before they, before you put them out and commercialize them and do that. Well, we talk a lot about ammonia engines, but ammonia engines aren't out there yet. And so, we all focus on what's in the combustion engine right now, which is basically, the everything from in the short term biofuels, LNG, the development of ammonia. Eventually, ammonia, you'll have different variations, whether it's bio LNG, synthetic LNG, whether you have, as you kind of move down the color streams of hydrogen and so forth. But I think this has taken probably a little bit longer than a lot of people have thought at this point in time, and it's quite frankly, it's to the advantage of new nuclear as you bring these this technology on. 10 years is not a long time relative to what is going on and what we've seen. It's taken us 20 years to get LNG into the market here. So I think the benefit that you're seeing is it's going to take a little bit longer. And quite frankly, that is to the advantage of new nuclear.
Wonderful. I think that's absolutely right. You pick up on one thing that you said, which is infrastructure, right? So we spoke about that this morning, setting out the program. It needs not just technology and customers, it needs infrastructure to build it. It needs that workforce, supply chain development, etc. And, one thing that's, and I hope I'm not swearing in church when I say this, Chris, the U.S. shipbuilding industry is in it's in a fairly squalid condition. It supports the U.S. Navy. It does that well, but I think, I get the impression that that's a tenuous supply chain. It should not be disrupted really by anyone. That would be a bad thing. It needs to be rebuilt, but the expectation that you would rebuild the infrastructure for a whole new industry at the same time as you develop technology, when we've got international partners, in Japan, Korea, and Europe, there are friends and partners and allies. Do you see a shift? I mean, let me reframe that question. The administration, previous administration, this administration, wanting to see acceleration in the maritime sector, wanting to see acceleration in the nuclear sector. Do you see a way of having these things come together in the next 3-4 years as, supported infrastructure projects that enables us to take those steps with partners overseas?
Yeah, I mean, when we talk about infrastructure, first of all, by the way, as soon as you talk about infrastructure, that's 10 years on the timeline, to be honest with you. So, as you begin to see kind of where that's going. I'm a naval architect. I spent my entire life designing and building ships. But it's very interesting. I mean, there is a school of thought that says if a country wants a sustainable naval shipbuilding program, that you really need to underpin it with a sustainable commercial shipbuilding program. Otherwise, there's really no kind of sustainability going forward. New nuclear provides us with an opportunity here to bring that technology in, again, to, as the Admiral said this morning, to be able to kind of address national security, energy security, and economic security. The pathways to get there, quite frankly, are going to probably vary. We have already seen, we've had foreign investment in some of our yards. I wouldn't be surprised if you saw more of that coming in here in order to bring that kind of technology and commercial practice in here. But at the same time, when you look at where you're trying to go with the concept of where the yards are basically being integrators, really focused on modularity going forward, it is quite possible that, existing yards, may not be able to completely handle that or reset themselves. And you may see the opportunity for greenfield yards coming up now to kind of automate the processes, automate the system, prepare themselves a little differently. Because new nuclear is a big disruptor. It's a, we've done a lot of studies relative to just putting reactors on 14,000 TEU container ship and a Suezmax tanker to understand kind of even from a design point of view, kind of what does that look like in terms of arrangements and things that we have to worry about going forward. We've done the studies that show, wow, you get much higher power, faster speeds. In some cases, because you're not really storing fuel, you actually have greater cargo capacity going forward. And we talked about the reverse cold ironing effect and so forth going on. But then when you start looking at, kind of where things are going forward and how this actually would get kind of put together, it does lend itself to kind of maybe we take a step back and revisit, that whole shipbuilding process. And, that's the beauty of why this could potentially be a really transformational opportunity for U.S. shipbuilding in collaboration with partners overseas, and how that would work together. Because I think as we move forward, it's probably going to be, success is going to be a team sport. I think a lot of this is not a technical problem. It is going to be, how trade policies get uncoupled relative to removing, for example, some of the, I will say, military biases from the commercial practice, because I think that's a big problem right now. That in itself kind of isolates everything moving forward. But I think as you go forward and look at that and begin to kind of work your way off the list, everything from standards, more ASTM standards, more industry standards, less military. We focused on the insurance piece. We focused on workforce development. We focused on uncoupling some of these policies relative to import and export. Then that will open up opportunities for here in the United States and, quite frankly, for abroad to set ourselves up going forward.
Standards is really a question, isn't it, Chris, of harmonizing some of these standards. So you're bringing best of maritime standards together with nuclear standards, and you're creating that link in between them. And that's an incredibly important foundation for this to happen. What is ABS involved in when it comes to influencing how that bridge between the nuclear standards for safety, security, and on the maritime standards, safety and security, which really is IMO, IAEA, or even nation to nation. How are you guys getting involved with that? Where are you seeing that going?
Well, I think that, that's a great question. It's really important. We talked a lot today about the technology readiness of the reactor technology, but, now you have to marinize it. So now, what you have to do if you're putting a reactor out to sea, you have to ask yourself all sorts of questions. What is the impact on ship motions and inclination? What are the safety shutdowns when something like that happens? What is the impact of humidity in sea air? What is the impact of ship vibrations in something like this? What are those unique power supplies that you need to bring on board a vessel relative to load balancing, once you to support kind of that reactor transformation of power. Again, it's a mobile reactor. What are those kind of physical security? How do you design a ship in such a way that you can get access to this reactor? So that whole kind of marinization piece is something that we work on quite a bit. I mean, in our criteria, we basically will assume that we are going to get a licensed reactor, probably from the NRC. We will get essentially a interface document, and then what we need to be able to do is be able to acknowledge that the ship systems essentially can fit into this interface document. And it gets, quite frankly, it gets past actually even the hardware. Now you got to talk about the crew. The international requirements, IMO has something called ISM. It's the safety management system. How does that work? How do you handle, crew situations if there is a problem? In fact, there was a collision I think about a week ago, it was a Russian nuclear-powered vessel that was collided, I think, with a with a bulk carrier. So, but how do you handle that moving forward? So, I think that brings it all kind of together and begins to kind of move this out so that it is not just a technology, but it is now it is really part of something a little bit bigger than that.
It's part of the ecosystem. It's the beating heart that makes it move forward. I mean, the one thing that I think we should all remember is the one thing that's brought us a globalized economy, the one that's brought us an interconnected economy of materials being transported around the world for refining and foodstuffs, minerals, etc. It's the big diesel engine. People think it might have been computers or it might have been containers or something like that. Actually, it's the big diesel engine. That was what's powered. You can look at the historical charts, and once you started introducing diesel after steam, that's where we got this. This is the big one, and getting that beating heart back into this in a different way, I think is probably something. I don't know how you see this, but is it something that, even though there are a lot of questions, do you think these questions are hard to answer necessarily? I mean, we've been doing this for 5,000 years.
Listen, Mikal, if we can put a man on the moon, we can figure this out. Okay, I mean, we can do that.
Right.
I think what just needs to happen is it gets back to relationships. What changes the pace and speed of something? Well, the government involvement. We talked about it a little bit today. I mean, it's what would be great. I know we have a couple of reactors that are being worked on the land side, but boy, I tell you, there's nothing better than having a maritime demonstration reactor put together to help understand all this connectivity that we're talking about between the impact on the ship, the requirements, the commercial aspects of it, the safety aspects of it. The quicker you can actually get that demonstrator moving, that is the quicker you're going to get this basically on a vessel.
And when we talk about the commercial aspect, of course, we're talking about economics, aren't we, Chris?
That's correct. I would love to hear, again, I'm a simple naval architect that just designs ships and builds ships, but in my mind, the economics, and I hear a lot about it, is actually quite compelling. When you take kind of in general terms a conventional fueled vessel, let's just say it's conventional fuel. I'm not even talking about this next generation of green fuels. And you kind of look at that over, let's say, a 30-year life, and you do the same basic calculations. You've got the value of the vessel. You've got the value of in this case it'll be the reactor, the fuel, when you kind of look at that, and then you look at things like what is the real value to the residual value of the fuel? What is that? How is the cost of fuel offset because of the compliance cost of the requirements coming forward? You actually paint yourself a picture that says, you know what, over a 30-year period, assuming you can get all this done and out there, the economics for a nuclear-powered container ship are actually as good or probably better, especially if you throw in the residual value and then the potential commercial. It's a different commercial model of licensing the reactor and possibly the fuel than what they have now. It is real upside for an owner. I'd love to hear a little bit more about that.
Well, I mean, it's an endless discussion, isn't it? Because there's so many use cases and so many different things you have to consider. I think it comes down to two things, Chris. I think it comes down to the speed and the design service speed of a vessel, right? That's the number one thing. What's happening today is that you talk about container ships that are designed for 24, 25, 26 knots, are sailing at 16, 17 knots. The bulk carrier fleet designed for 14 and a half knots are sailing at 10 and a half, 11 knots. The tanker fleet designed for 15 is sailing at 10 or 11. It's all there to save fuel. There's a sort of save economics.
And reduce emissions.
You reduce emissions, right? Try to comply by going slower and doing less. I think if you go the opposite direction and you go back down that road of design service speeds of vessels that are 25, 26, and more, up to 30 knots, north of 30 knots. I mean, back in the 80s, we had container ships designed for 35 knots. And with cheap oil, they could do it, right? We don't have that now. And I think if you go back to that and you're seeing that system economics, right? Owners don't just think about, and charterers don't just think about the fuel inside freight calculations. They think about the investment opportunity in something that gives them system economics. If you're operating a fleet of container ships, fleet of tankers, fleet of bulk carriers, you're optimizing that fleet for a cargo program that you are an integral part of, and you see it from that perspective, this knocks the socks off pretty much anything else that's out there. And things like residual value, that helps with the capex, because clearly one thing that we have with nuclear is very different from what we have with the current way of feeding combustion engines with energy. Is we have a low, at the moment we have low capex, and then we have a variable long-term OPEX that's volatile but follows our trading pattern as we go along. You build fuel cost into the freight calculations, and you're basically using that as a way of creating arbitrage in the market. Here you've got a lot of capex up front, because your capex is also including the energy that you need for the total life for that vessel. So you have no volatility in the cost of propulsion, which changes the tradable landscape around us from being one that's fuel related to one that's being market supply demand driven. Your baseline is the same, but how you then finance that capex is what becomes really interesting. Then if you can bring residual value of that fuel, so you're effectively saying instead of buying it, you're now leasing it. Just like if you leased a car with a high residual value, you'd pay very little, right? It's the depreciation of that asset that matters the most. Then those two things combined, I think you start to open a whole new Pandora's box of what's possible. And it's a fascinating world to step into.
Yeah, I mean, you completely invert the business model from an owner's point of view. You pick up some added advantages along the way. But at the end of the day, when you really kind of, you get the near-term potential benefits, higher speed, no bunkering, and quite frankly, possibly even more reliable and lower, asset management costs over the life of this. And then at the very end, you're no longer, it's just the residual value of the steel, because that's normally what it's the residual value of the potential fuel, which completely changes things around. I mean, can you imagine, ship owners they are basically now licensing the reactor, and they're basically licensing the fuel, which interjects another element into a kind of a commercial model. The charters are going to be tied to this, because I think going forward in this world, it's not just the owner, it's the charterer. They also have now some skin in the game, not just to comply with the requirements, but quite frankly also, they have financial interest in how this is done. So it's really neat. It's just gonna, right now the challenge is to, what is our playbook moving forward to continue the pace and speed in order to move this. And 10 years, you think it's a long time, but when you look at kind of where the other potential fuels are and you kind of see where things are moving, boy, you're in the zip code.
Indeed. Chris, it's been fantastic having you up here today, and we hear your insights. It's been wonderful. Just before we go though, after a lifelong service to this industry, and the Titan of Industry title that you rightfully earned,
It doesn't resonate with my kids.
What's your hope for the future, Chris?
Listen, personally or from an industry point of view? My own personal one. Listen, I'm going to be looking forward. I hope I have the patience to spend more than 10 minutes a day playing hide and seek with my grandkids, to be honest with you. But I will say one other thing, and on a more serious note. We talk a lot today, and I'm sure we'll talk a lot this afternoon, about technology and how the importance of technology and, how everything is being driven by technology. But to be honest with you, the real heroes for whatever we bring forward are people. And we need to probably, continue to talk more about people, because people, unlike technology, have a common sense, have a sense of humor, and have instinct. And it's going to be the people that are going to make this work, that's going to bring this forward. And as whatever the fuel is, whatever the technology is, whatever the system is going forward, collectively, it's the people that are going to drive this. And that's really important going forward.
Couldn't agree with you more, Chris. And on that note, thank you to you and all the wonderful people at ABS for supporting this program. And, it's been great having you with us.
Great. Thank you very much. We appreciate it.